participants are joining. They will be joining. We will let them in as per their registration. Good morning, namaskar, and welcome to the fourth day of Advanced Poultry Nutrition and Feed Formulation webinar. I am Dr. Vivek Regmi, the coordinator of this webinar and Director Markham at Vet Nepal. For those who missed out the previous three talks or are participating our webinar for the first time, I'd like to say a few things about Vet Nepal. Uh, I'm sorry. Vet Nepal is primarily focused on sharing news, information, and knowledge in the field of veterinary science, livestock, and poultry industry. Besides disseminating the technical information and knowledge of livestock and poultry industry to farmers and scientific information to veterinarians and vet students, we also intend to serve as an outstanding e-platform to promote the expertise, products, services, facilities, and prestige of any veterinary related business. This particular webinar aims to train poultry veterinarians and veterinary students about the various aspects of poultry nutrition and feed formulation, from ingredient selection, understanding of the digestive physiology of chicken, understanding of the nutritional requirement of chicken breed and type of bird to least cost formulation. We have invited different national and international poultry nutritionists, professors of poultry nutrition, veteran formulators with decades-long experience, engineers and software developers as our keynote speaker to deliver their talk on the topic of their expertise. We are extremely thankful for your overwhelming participation and the insightful presentation of our keynote speakers. Above all, we feel blessed to enjoy the interactive talk session after each presentation, which has put much light on different practical aspects of poultry nutrition. It is a matter of immense delight for us to witness participants from different nations and also a speaker from Nepal, India, and United States of America. I again request our dear participants to mute their microphone during the talk session, and please feel free to put your questions in chat box. And we humbly request the participants to appear in this platform with the name with which they have registered. And talking about today's session, we have 4 topics: the use of prebiotics, organic acids, and essential oils in poultry feed. For the first topic, which will be delivered by Dr. Susim Mukul Ray, Genex Animal Health. Likewise, the second topic is the 360-degree approach of sustainable feed milling solution and quality management, which will be delivered by Evan Priyadarsani from EW Nutrition. Analysis of raw materials and quality overview in field and lab by Dr. Dinesh Bhosle from AB Vista, and enhancing the performance through quality premix procedure, which will be delivered by Mr. Harjot Singh from Lark Engineering. So without further ado, in order to present today's first topic, I would like to introduce you to today's first speaker. Our keynote speaker, Dr. Susim Mukul Ray, is an MBSc gold medalist in veterinary microbiology and is serving as a head of technical and promotion in Genex Animal Health. His expertise lies in poultry nutrition, vaccines, and clinical immunology, disease diagnosis and control. Before this, he worked as Group Product Manager at Zydus Animal Health from 2017 to 2019. From 2013 to 2015, he worked as the Senior Technical Officer at High-Tech Hatch Fresh Private Limited, where he monitored the broiler integration operation of 3 different zones of India with the placement of more than 15 lakhs per month. And he spearheaded the Poultry Disease Diagnostic and Nutrition Laboratory. As a product manager, Dr. Ray monitored the company's poultry business across India and abroad from 2015 to 2017 at Rosary Biotech Limited, Mumbai. He is also an eminent poultry scientist with keen interest on clinical and vaccine immunology. So Dr. Ray, The floor is yours now. Please proceed ahead with your presentation on use of pre and probiotics, organic acids, and essential oil in poultry feed. Thank you.
Thanks, Dr. Vivek, and I welcome all the veterinarians, young budding veterinarians, government veterinarians, all poultry professionals, and who might have joined over from any parts of the country. And I'm honored to having me here, to giving me this opportunity to talk about this topic today. So let me share my screen, and I would request the organizer to confirm once you're able to say this. Can see my screen, Dr. Vivek? Can you just confirm?
Yeah, it's visible.
Yeah. I just want to remove the navigator over here. Just allow me a few moments. Thank you. So, as explained by the organizer, that I'm going to talk about prebiotics, probiotic, organic acid, and essential oils in poultry feed. And this, as you can see, this is it's a vast topic to be covered, and each of these components that we are going to talk can have a separate session. So we need to concise or consolidate the information, the transaction of information that will happen today. And I would like to touch upon most relevant points related to these components. So here is the talk outline. We'll start with the gut health problems, and we like to highlight how are they manifested. And then we take these components of that improves the gut health, that is probiotic, prebiotic, essential and organic acids separately. And finally, optimizing the application of probiotics in poultry diet. I would like to dedicate a separate section on that, and before concluding. Just before diving into the topic directly, I wanted to mention that these components that you see, probiotic, prebiotic, essential oil, and organic acids, they are extremely important in terms of fighting the antimicrobial resistance, which is one of the global threats. And with the restriction of use of AGP or medicated feed additives, the importance of use of these components alone or in combinations have become very important. So going forward, they will be the resort to poultry farming without AGPs or critically important antibiotics being banned or restricted. So the gut health problems in chicken is manifested through different routes or sources of infection. So it could come from the feed. The feed raw material digestibility could be poor, that lead to poor digestion. It would come with higher microbial loads in the feed or raw material. That also delivers a lot of inoculum of pathogen load in the chicken gut. So this sudden change in the microflora would cause microflora imbalance. And to intensify that, there are other parasites like intracellular parasite like coccidia, primarily Eimeria species from Azarulina maxima and tenella. They also causes cellular damage or intestinal epithelial cell damage. And it further intensifies the microflora imbalance that is happening already in the chicken gut, is intensified by the coccidiosis, and combinedly it would or may lead to necrotic enteritis. But if the coccidia parasites are well managed by using anti-coccidial program in rotation and shuttle, Then the microflora imbalance would lead to bacterial enteritis. So 3 different cases of bacterial enteritis are seen, primarily the Clostridial enteritis, which of course sought a lot of attention, while there are non-clostridial mediated cholangiohepatitis or non-clostridial enteritis that are also found, and all these would lead to poor performance. So the gut integrity here in the right side, you can see the loss of gut integrity that happens. It could be due to bacterial enteritis alone or combination of coccidiosis and bacterial enteritis, which is far more severe in terms of causing loss of performance in chicken. Just I'm not able to. Yeah. So how to mitigate these challenges at different routes of entry or different at the level of the source of entry. So here on the right hand side, I've shown this the schematic diagram that shows how it can be controlled. For coccidiosis, we use coccidiostat. For control on the microflora, we use medicated feed additives, which of course is gaining a lot of attention for restriction in countries like India. Already it has in place in developed countries like Europe and United States. So we are focusing on alternatives to MFA that are prebiotics, probiotics, and essential oils. And to reduce the microbial load in feed that is coming through raw material, or to sanitize the chicken gut through, we use organic acids either in water or feed as a feed sanitizer. So combination of all these 3 components would lead to implementation of total gut integrity, or achieving total gut integrity in the chicken. So today's session, we'll be restricting our discussion to the components that are highlighted. So we start with probiotic. So probiotics are live microorganisms which, when administered in adequate amounts, confer a whole health benefits on the host. So 2 things are important. It has to be live, and they need to confer health benefit on the targeted host. In this case, it is chicken or poultry. So in this slide, you can see a newborn chick when born in the wild. They get complete this flora from their parents, the mother hen. So that offers complete protection to the gut. While in commercial operations, the domesticated the birds which we rear in backyard poultry, they might get this flora from mother hen, but commercially reared ones are separated as soon as the eggs are laid. So never it happens that the newborn broiler chick or layer chick comes in contact with their mother hens dropping. That is why we need to offer external sources of probiotic that bridge the gap, what is happening in the wild, that you can see in the right hand side. This shows the importance of application of probiotic in commercially reared broilers and layer chickens, and in today's scenario in the industry, which is going to offer the protection and exactly simulate or mimic what is happening in the wild or in the nature. And this is very important because we are trying to match the flora or the quality of the flora that is passed on to the newborn chick from their mother hen and artificially. So please take a note of this. Now coming to the application part of the probiotics, so it is either given through feed or water. Almost 80% of the volume is contributed by the feed and 20% through water. There are certain characteristics of probiotic species that are required for feed application. For example, it should be very robust, like thermostable. It should be, that's why spore-forming probiotics or bacterial strains are preferred. And of course, it should be very stable in the chicken gut environment, like bile salt and gastric acid or pH resistant. So some candidates which are preferred or established in feed applications are Bacillus subtilis. So most of the species under bacilli, Bacillus leishoniformis, Bacillus amyloliquefaciens, proprietary Bacillus species which are characterized and developed by the marketing company, or they're collaborating with some basic manufacturers. So those are proprietary strains. Clostridium butyricum, it is also an endospore forming bacterial strain, a bacterial species. And Saccharomyces cerevisiae, they are also known to have higher thermostability. For water applications, both spore forming and vegetative organisms can be used because we don't have that harsh environment of feed manufacturing process, as you were seeing here. I'm sorry. Need to fix this. Yeah. So this vegetative organisms in the genera Lactobacilli are used predominantly. Of course, there are some spore formers also used, like Bacillus coagulans over here. You can see initially it was in the Lactobacilli genera. The genus was Lactobacilli and Lactobacillus sporogenis. The species was sporogenis. Later on in Burgess Manual of Classification, as it retained the spore forming capability, it was found. So it has been reclassified as Bacillus coagulans, or otherwise it was initially a Lactobacilli bacteria or lab bacteria. Enterococcus faecalis, Streptococcus, Bifidobacteria, Pediococcus acidilactici, these are all vegetative cells. They cannot form spores, and they are preferred for water application. And of course, the criteria of having, thriving in the bile salt environment and gastric acid pH or wide pH range is also relevant for water application. So in summary, spore formers are preferred in feed applications, while vegetative organisms are used in water application. So how does this probiotic perform, or what are their mode of actions? First is by controlling gut pathogens. So they control gut pathogens by producing some antimicrobial compounds like bacteriocins, lipopeptides, competition for the nutrients with pathogens, and competition for adhesion sites with these pathogens. The second mode of action is altering the microbial metabolisms, where they increase production of some enzymes, decrease in some enzyme activity that is not favorable for the host. And third, by stimulation of immunity, which are different components of immunity, like mucosal immunity at the site of intestinal epithelial cells. They bring about immune homeostasis. They enhances the innate immune response through higher macrophage activity at the mucosal sites. Here it is the intestinal tract, and also indirectly help in increasing antibody levels, since you have better immune homeostasis or preservation of nutrients for production rather than fighting off infections against pathogens. So they strike that balance. So we started the definition, the section of probiotic with the definition of probiotic, right? And the definition says that those probiotics are live organisms, and these are meant to offer health benefit to the host. So when we say that it is meant to offer health benefit to the host, we meant to say that for example, here in our case will be chicken, that there should be consistent benefit or positive impact on the health. And for chicken, the marker, for example, in broiler chickens is very easy. The marker of health benefits is in terms of visible difference in reduction of mortality, in improving performance, or if we do measure the correlates, like we are measuring the histomorphometry of the chicken gut, then the villus height by crib depth, all these parameters has to be improved consistently. But if we see the research reviews, there are variations in these in the trial outcomes. In some of the research reviews, if you see, there would be significant improvement in growth indices, like body weight gain, FCR. While some of the research reviews says numerical or insignificant improvement over control. And in fact, there are few publications that also mention about the negative effect of using probiotic, which is this clearly the data shows that the performance are having numerically inferior to performance parameters are numerically inferior to the control. So this just to substantiate the fact, this is one of my publications where we found that this is on the left hand side is a negative control. The others are the different formulations of probiotic, and you can see the F1, one of the formulation in one of the treatment group had inferior villus height and crib depth. Specifically, the villus height was higher, but the crib depth had increased, leading to inferior VH by CD ratio, villus height by crib depth ratio than the negative control or the control, where no treatment was done. And we could see the translation of this, what has happened in higher crib depth, although the villus height was higher than the negative control, in the daily weight gain of the flock, and which was not statistically significant. And even the other parameters were almost similar to the negative control. And this finding was also, is also, in alignment with what we see as a negative or minimal or statistically insignificant difference than the control. So, and there are other publications as well. I just wanted to cite one of them. So when a probiotic is defined to, defined in a way that it has to offer health benefit to the host, why it would have such inconsistent result? Even why it should have negative impact at times? What could be the reason? So before understanding the rationale behind the possibility of having such inconsistent, why it would lead to such inconsistent result, let us understand the features of an ideal probiotic. The probiotic should be a strain capable of exerting beneficial effect on the host that we have seen in the definition. Various mechanism. The mechanism also we have explained. It should be non-pathogenic and non-toxic. Of course, it cannot have these negative parameters. It should be present as a viable cells in large numbers that can, outrun the challenges that the target host is facing. In case poultry, there are plethora of pathogens, bacterial pathogens that are daily challenging the chicken gut. Number 4, that it should be capable of surviving and metabolizing in the gut. That should be, I mentioned about the bile salt resistance, wide pH resistance, even the pelleting process, the feed manufacturing process, it should thrive. And that brings to the last point as well, that it should be stable and capable of remaining viable for a long period of time. So under storage in the field condition, when the commercial products are going and kept over a long period of time, it should be really viable. And also as I mentioned, in the feed manufacturing process. So in my opinion, these first 2 points are extremely important. You need to focus on this. So here we present some of the points or the reasons that could lead to such inconsistent results. This is our in-house finding on while we did a study or project on probiotic strain screening selection from chicken gut in last 4 years. We found that bacilli species, within bacillus species and subspecies, Bacillus subtilis, subspecies subtilis, or you take any Bacillus amyloliquefaciens, the strains within a species under at the strain level, they vary a lot in enzyme expression and also various antimicrobial effects against different pathogens. And that is one of the cause of such variation in performance. So the strain variation is extremely important. Just like us, we are Homo sapiens. So in attributes and certain qualities, we do have much variation. We all, every individual human beings are not same. Similarly, at the under species level, these bacteria species tend to vary, across strains. And this is what we, on the right hand side, it shows that different strains of bacilli species, we primarily targeted subtilis. We did xylanase assay as one of the indicator of expression of enzymes. And you can see that they are varying a lot across the strains. And the variations are almost 2 to 5 times if we compare the least expressing strain versus the highest expressing strains, and of course at different passage level. So the antimicrobial effect, to show that how it varies, this is one of the findings, research findings at our lab at Digestion Center, where we could see the variation in antimicrobial effects across different strains. These are some of the isolates that we could screen, and these are other commercially available strains where we could see the effect on gram-negative bacteria and gram-positive bacteria. Gram-negative bacteria, we chose Escherichia coli, Salmonella typhi, whereas gram-positive Staphylococcus aureus. So the strains varied a lot in plate antagonism assay and zone of inhibition. So this is very important to understand that if your strain varies in anti-infective property and performance boosting property, of course, the production parameters are, every time you do an experiment or feed this probiotic to the chicken, the performance is going to vary, provided if you're not aware of the strain of the probiotic species you are using. The second point is the safety profile of the strain. So if you are using a Bacillus subtilis and you're not sure which strain of Bacillus subtilis you are using or which strain of Bacillus amyloliquefaciens are using, then you might end up in a negative performance as well, because certain isolates of Bacilli species are also having hemolytic property and cytotoxic property. So you need to isolate, of course, a non-hemolytic, non-cytotoxic strain and to have that in the product. So strain characterization is very, very important. On the right-hand side, you can see one strain of Bacillus species is having hemolytic property, another species is not. So this is what we are going to choose, or we would like to have in our product on the right-hand side. The design of the experiment also have, impact on the performance or the difference of performance between control and the treatment. Sometimes we design experiment without even modest amount of challenge or decent amount of challenge. Without challenge, the fullest potential of a probiotic does not come to the surface. So challenge is extremely critical. So that means presence of bad microflora is also important to create a difference or statistically significant difference between the treatment and the control. So this doesn't happen sometimes in the experiment. Poor stability of some strain in the chicken gut conditions. So this is, again, you need to understand that if you are not having the strain characterized under a species level, you are not aware of the fact that what kind of stability it has. Just by simply talking that Bacillus species are spore former doesn't mean that all Bacillus subtilis and the isolates or strain under Bacillus subtilis or Bacillus amylolucifaciens or lecheniformis for that matter would have the stability, same level of stability in the chicken gut conditions. In fact, these are all soil saprophytes. So they get equal opportunity to get inside the chicken gut. So there are other bacilli species like Bacillus coagulans, Bacillus valegensis, Bacillus siamensis. These are available in the soil. So which of these strains under the species, each of these species are capable of surviving in better or effective manner in each of different hosts, for example, in chicken? It's a matter of question once you isolate them and standardize them and characterize them. So you cannot generalize across these species that every strains are going to have same level of stability. The fifth point is lesser potential in commercial products that actual claim. This also happens sometimes of the poor quality of the quality control management of some of the marketing products being marketed. We need to check whether whatever potency that is claimed is there in the product or not by quality cross test. And the last point is the application error. That's the reason I have kept a separate section on that. They're trying to modulate the flora when it's too mature for any significant change. And this is going to have no benefit to the host if your application is not optimized. So before you incorporate any probiotic inside the product, we need to understand the screening, selection, and evaluation of the strain. You need to do that. That should go across safety profile of the strain, stability and viability of the strain, the performance boosting effect of the strain, and finally the antimicrobial effect of the strain. Once you are confident on all these parts and you have chosen your strain, and then only it is suitable for use for the targeted host. So I say that know your strain characteristics before incorporating the product, or whatever product you are using, you should know about the strain of the probiotic that is available in the market. So this is one, the summary that of the screening activity that we did. Basically, it also echoes with other laboratory or university research. Many research workers have done this kind of screening studies in development of newer strains or novel strains. So just to give you an idea that isolation of the strains against a targeted host should be preferably be done from the targeted host itself. In this case, we'd have done from chicken gut, taken healthy chicken gut, isolated bacillus strains, then screening of bacillus strain based on desired characteristics, like I already mentioned about safety profile of the strain. So it should be non-hemolytic, non-cytotoxic, stability, thermostability, bile and gastric pH resistance. Then based on performance parameters like NSPA's expression capability, like I showed about xylanase expression profile, amylase, protease expression. Then antimicrobial effect, we can like plate antagonism assay, surfactant assay. And finally, once you are happy with the strain that you got after screening, you can do in vivo trial for validation of the effects that you are seeing in vitro. So this kind of trial should always have a challenge in place. So preferably a necrotic enteritis model would be great. to validate and re-examine or evaluate the performance of these strains. And finally, once you are happy with the strain performance in vivo, it can be further optimized for growth condition for commercial scale up, and then translate into the commercial product for commercialization. With such activity done, you can you can believe that can have a faith that you will get a consistent results every time you are putting this probiotic into test in chicken. To make you understand what we have done basically on probiotic strain characterization and our deep understanding about probiotic, and with an objective to replace AGP and antibiotic going forward, I have created a video for you. It's a 1.5 minute video. I think it would be very educative. Please go through that. But before I do that, I need to switch to my computer's earphone. For some reason, yeah.
Yes, so please.
Probiotics are essential component of chicken diet. But are they all? To categorize probiotics in generally recognized as safe, they should be non-hemolytic and non-cytotoxic. Moreover, there are wide variation across different strains of probiotics within a species.
I'm just starting the video from the beginning. Yes, you might have missed some of the audio tracks. Dr. Vivek, was it audible?
Yeah, audible.
Yeah,
you missed that.
Probiotics are essential component of chicken diet, but are they all safe? To categorize probiotics in generally recognized as safe, they should be non-hemolytic and non-cytotoxic. Moreover, there are wide variation across different strains of probiotics within a species. This results in poor and inconsistent results. At Zydus Research Center, we have undertaken extensive research in screening and isolating probiotic strains from chicken gut in a project called Microbiome Innovation. More than 800 strains were isolated based on various parameters. Finally, most suitable strain, Bacillus siamensis ZMT02, was selected. Thus, the novel strain, Bacillus siamensis ZMT02, is completely safe for chicken. It can consistently express NSPAs in large quantities based on substrate availability, which in turn improves digestibility and growth indices of chicken. The strain is effective against E. coli, Salmonella species, Enterococcus species, Staphylococcus aureus, and Clostridium perfringens. In addition, the novel strain has been shown to exert anti-inflammatory activity leveraging immune homeostasis. Last but most importantly, the strain has excellent stability in pelleting conditions and gastrointestinal tract of chicken. Bacillus siamensis ZMT02 fuels our probiotic product lineup and is available in both feed and water-soluble form. Improval VFS and MS are the key to total gut integrity.
okay, so
To give you this perspective that how we had just a sec. The video was to give you a perspective that how we have screened and isolated novel strain and characterized up to strain level, and we ended up in Bacillus siamensis ZMT02, following the exact pathway that that I have showed you a little while ago. And all these strains, apart from Siamensis ZMT02, we had selected and screened other strains as well. There are 3-4 more strains. Those were all non-hemolytic, non-cytotoxic, and very powerful in terms of expressing NSPAs, and has been tested again plethora of pathogen profiling like gram-negative bacteria, gram-positive bacteria. That's relevant for poultry. And once you have done that, and also of course we have done all these stability tests relevant for poultry. So once you have done that, you can ensure that the probiotic that you are using are going to exert consistent results in the field, and can have the potential to replace the IGP and antibiotics going forward. So with that, I go to the next section, that is prebiotic. So prebiotic is exactly should be dealt after probiotic, or before probiotic. So they are very much related and are complementary to one another. So basically, these are non-digestible, selectively fermented ingredient that are naturally present in the raw materials and also can be given externally. By mean that it is naturally present in raw material, I'll come to later on and explain that. So they are non-digestible fractions or selectively fermented ingredients, which in both composition activity in gastrointestinal microbiota, it influences positively and confers benefit to the host. So in very simple language, they are food for your probiotic and does the nourishment of the microbiota. So once you give them the probiotic that you are feeding the chicken, if it is a natural component of the chicken, of these probiotics are the natural component, then they will be benefited much effectively than certain strains which are not a natural component. So basically, applying a prebiotic along with probiotic would ensure better proliferation or replication of probiotic in the chicken gut. So here are commonly used prebiotics for poultry. So it can be classified. I have classified it in 2 types. One is established and another is emerging or new variants of prebiotic which are being tried. The established ones are basically different derivatives of oligosaccharides. As I told, these are non-digestible components. So once they are non-digestible, they go. It is not possible for the host, in this case poultry, to get it to digest it or break it down into simpler molecules. So the bacteria does it. The probiotics, the bacterial strains in the form of probiotic or the beneficial microflora does the job, and they do it in the chicken gut when the colonization is almost completed, and they do fermentation of these components and produce volatile fatty acids. So there are various established prebiotic like fructooligosaccharides, polyfructan ululin, galacto-oligosaccharides, 1,6 beta-glucan, and mannan oligosaccharides, D-mannose, and basically these 3 comes from each cell wall derivative. Some emerging prebiotic candidates are lactosucrose, xylo oligosaccharide derivatives, isomalto oligosaccharides, and oligosaccharides derived from soybean meal or soybean. Here we see some characteristics of ideal prebiotics and their mode of action. So as these are not digested, they are not hydrolyzed also chicken gut, and neither they are absorbed. So with this, what happens is that the probiotic takes the advantage and they produce a lot of volatile fatty acids, that is SCFA, that is short chain fatty acids. With the production of volatile fatty acids, the pH of the gut content or luminal gut content get lowered or reduced, and once the pH gets reduced, it favors growth of some beneficial microflora and certain pH sensitive pathogens like Escherichia coli and Salmonella. When these prebiotics are selectively stimulating growth of one or limited number of beneficial bacteria, it will eventually lead to better biomass or microflora, improve the dropping characteristics and gut health. It can also beneficially modify the intestinal microbial activities by, again, influencing the particular type of microflora, and that would enhance vitamin B synthesis, positively affect mineral absorption, decrease in blood cholesterol level, and also reduction in ammonia and urea excretion. And there are certain prebiotics which directly affects the pathogen, or you can check infection by binding to some strains of pathogens like Salmonella, Campylobacter species. And the example of such prebiotics are mannan oligosaccharide. I'll come to the next section. So it has a direct impact in decreasing the enteric challenge and improving the gut health. And finally, it can positively modulate the immune system. And when it does that, it increases resistance against enteric infection. So not all prebiotics are doing this. There are specific prebiotic having specific set of characteristics, and this specific set of characteristics is going to influence or have a positive impact in the poultry. In the next section, the slides, I've just discussed about the example of these prebiotic candidates, which is having these characteristics. For example, not hydrolyzed or absorbed, all oligosaccharide derivative will have this kind of characteristics. So eventually, they will help in lowering the pH of the gut by production of volatile fatty acid. And certain oligosaccharide derivatives, they have selective property of stimulating beneficial microflora. All oligosaccharide derivatives have beneficial, this advantage of modifying the intestinal microbial activities. Regarding elimination of certain pathogens directly from the chicken gut, the role is played by mannan oligosaccharides or MOS. It can directly bind to certain strains, not all, certain strains of gram-negative and gram-positive bacteria, and certain is cell wall derivatives like 1,6 beta-glucan. This is one of the prebiotic that can positively modulate the immune system, the innate immune system. Now here I wanted to mention you about one point, is that there is another beta-glucan, that is 1,4 beta-glucan, and we get this from cereal ingredients. Beta-glucan is available in fungi in the yeast, and also cereal ingredients like bajra, oats. And 1,4 beta-glucan is very toxic or have potential ill effects in chicken gut. And while 1,6 beta-glucan, this is the glycosidic linkage or bond. It is present in fungi and yeast cell wall. It acts as a prebiotic. So don't get confused, because 1,4 beta-glucan is an anti-nutritive factor, and it doesn't favor nutrition, while 1,6 beta-glucan is a prebiotic. So the glycosidic linkage changes the entire story. So this we come to essential oils. So essential oils are monoterpenoid and oxygenated monoterpenoid compounds. They are produced by secondary metabolism of aromatic plants like pine, eucalyptus, mentha, and they have certain pharmacological properties, and they are volatile in nature also. So some of the examples of essential oils and their mode of actions are eucalyptus, we have used primarily in different formulations in poultry. Both water soluble and feed paste are available. I'll come to that later on, but here we need to understand the pharmacological effect of each of these components. From eucalyptus, we get 1,8 eucalyptol. It has got antimicrobial, anti-inflammatory, and immune system stimulating property. It is very strong antioxidant as well. So primarily used in respiratory ailments, in treating respiratory ailments. essential oil component from eucalyptus are used. From mentha, we get menthol and neomenthol and eugenol. So they are also very strong components for treating respiratory ailments like respiratory decongestion, and also have decent antimicrobial property, anti-inflammatory property. Ajwain, we all take ajwain. So these two essential oils are very, active component of essential oils are very important. Ajwain contains thymol and carbapenem, and thymol and carbapenem and cinnamaldehyde have been widely, I think it's not mentioned over here, cinnamaldehyde is also there. Cinnamaldehyde, thymol and carbapenem widely used for enhancing the gastrointestinal tract performance of a chicken. Because the essential oils are primarily used both for treating respiratory ailments as well as improving the gastrointestinal tract performance or production performance of chicken. Why it is having so much impact on gastrointestinal tract performance is because of its strong anti-inflammatory property. And this strong anti-inflammatory property brings immune homeostasis, just as what probiotic does. Because gut inflammation, if is under control, then the pathogens, the tight junction in the gut, it doesn't get compromised. It doesn't get leaky. So with that positive attribute, the active components like thymol and carbapenem exert beneficial effect in improving in functionality of the gastrointestinal tract. Besides, it also have a decent, antimicrobial property, and also can be used. This component can be used in respiratory ailments because of its bronchodilatory action. From pine tree, a specific essential oil is very important, that is abietic acid and pinene, alpha and beta pinene. It has specific anti-inflammatory actions and antimicrobial actions, and also used both for gastrointestinal tract and treating gastrointestinal tract and respiratory ailments. Camphor contains 1,8 cineol and eugenol. Both mentha and CU can have both the active components same, and it is also used as an antiseptic, antispasmodic, and anti-inflammatory compounds. These are the primary action of the active components. So when we talk about the essential oil in improving the performance of the chicken, primarily on the mode of action on the gastrointestinal tract. So we need to discuss, we can't avoid, we need to discuss about the antimicrobial action of these essential oils. I told previously that in the previous slide that the essential oils are primarily acting as anti-inflammatory compound in the chicken gut. So that brings about immune homeostasis. Not all component does this activity. There are certain active component like thymol and carbapenem, which are having, or cinnamaldehyde, having very strong anti-inflammatory action. But beside that, the direct antimicrobial actions is also extremely important, and it is at times better than even certain antibiotics. So we come to that in the later slides. But here we, it is shown that how in different routes, routes of action, these essential oils exert their antimicrobial activity. So it is multifaceted. It can alter the cell membrane permeability and causes leakage of cations from the cell cytoplasm of the bacteria. That leads to lysis. It can interfere with the ATP pump and cellular ATPase, causing energy depletion. It can interfere with the quorum sensing of the bacteria. Quorum sensing is a mechanism by which one bacteria communicates with another bacteria. Just like I'm communicating with you, we have a specific language, and you understand that language of communication. For them, there are specific molecules that are secreted by one bacteria that binds with the receptor of another bacteria, and thereby they communicate with each other. So they interfere directly with quorum sensing. they cut down the chain of communication. That also would help in reduction of biofilm formation, and it has been established. So it is different mode of action, a multifaceted mode of action also ensures that resistance is not built up easily. So against essential oils, it's very difficult to gain resistance by the bacteria. In fact, another important advantage with that, here I have written here that these some essential oils like thymol and carbachol, when applied with certain antibiotics like fluoroquinol antibiotics, has synergistic effect. Even in certain area where the isolates were found resistant against a beta-lactam antibiotics, simultaneous use of essential oil with these beta-lactam antibiotics have been shown or proven to alter the resistance of those isolates after few years of use, or after definitive some time interval was given. And this reversal is plasmid mediated reversal of resistance, what you can see here. So you have to use antibiotic along with essential oil in conjunction, and you can expect that the resistant bacteria might change back to susceptible bacteria after fewer applications. And of course, it has a synergistic effect with antibiotics. So definitely it will have a synergistic effect with probiotics, but we need to see the compatibility of the probiotic strain with the essential oils, because again, it causes direct damage to the bacterial cell wall. The spore forming probiotics are resistant to essential oils, even like Bacillus subtilis and Bacillus valigensis and Bacillus siamensis, but more studies are warranted in conjunction. This slide shows the MIC of use the essential oils against pathogens. I just told that it sometimes are comparable or even lower than the antibiotics. So carbachol and thymol, it has a MIC ranging from around 300 to 150 to 400 or 400 plus ppm for Escherichia coli, Staphylococcus aureus, Pseudomonas aeruginosa, and Candida albicans. And this has been proven over a large span of time, and this from this studies were in 1997 to 1998. Still now, if you go to the literature, established published literature, you will see that the MIC values has not increased much, and these MIC values are even lower for certain isolates of these pathogens mentioned. So over a period of time of like 20-25 years, the MIC remaining same means the bacterial pathogens are not getting resistant, not acquiring resistant. So they are very helpful in that respect, and can be a very strong alternative against the antibiotics or AGPs. With that, we come to the organic acid. Now, organic acids are, the action of organic acids are almost same as that of probiotic in certain aspect. I'll discuss about that. But the use of organic acid are basically for feed and water sanitization, and then acidification of the chicken gut. That is specifically the upper gastrointestinal tract. To be more specific, the crop. Why crop? Because crop is a place where, first of all, the chicks, when a newborn, they do not have low pH in the crop. The pH of the crop is as high as the other section of the gut, this mid gut and hind gut, because in the newborn, the proventriculus doesn't start secreting the hydrochloric acid in good quantity. So the alkalinity of the, or close to normal pH of the crop would favor colonization of a lot of bacteria, and crop is a storage of feed for a long period of time. So it has been shown that salmonella colonization is potentially high in the crop. So crop acidification reduces salmonella impacting chicken. So organic acids are used for those purposes, initially in water and through feed acidification. So what are organic acids? They are organic compounds that have acidic properties, and the property is mediated through carboxylic group. The carboxylic group has these, you can see the COOH, it has the hydrogen ion, and they are used for sanitation of water and feed, and eventually the gut of poultry. The general formula is RCOOH, where R can be any alkyl or methyl group. Again, regarding application, as I mentioned, it can be given through feed, almost 70% in the feed application and 30% in drinking water application. These are commonly used organic acids in poultry. And before I discuss about them, you need to understand SCFA, MCFA, and LCFA. So SCFA are short chain fatty acids. The number of carbons should be less than 6. MCFAs are having carbon numbers from 7 to 10. And long chain fatty acids have a carbon number greater than 11. There are certain derivatives of saturated straight chain fatty acids. Short form it is called DSSFA. And these are the lists. I'll come to that in detail. And you can see another terminology called pK. pK value is the pH at which organic acids are 50% dissociated. I'll explain this in the next slide. So when the pH of the environment is greater than the pK value, the organic acids will be more in dissociated form. Please take a note of this before we go to the next slide, because this has some important implications on the action of organic acid in the poultry. Now, you can see most of the organic acids are having pK value between 3 to 5. These are the lists. These are the exhaustive list of organic acids that are used. Those are used in the feed or water acidification. Primarily, the SCFA having carbon number lesser than 6 are used for, lowering of pH. Because in the upper gastrointestinal tract, since the pH, the pK value is much lesser, even lesser than 5 or more, most SCFAs, they primarily act through lowering of pH. So from formic acid to caproic acid are short chain fatty acid because the carbon number is lesser than 6. Caprylic acid is a medium chain fatty acid, and not many products available with caprylic acid, and they are basically used in the feed, where blends of SCFA and MCFA are used preferably because they also have a different actions on gram-negative and gram-positive bacteria, and susceptibility of the bacteria also varies across SCFA and MCFA. I'll come to that again in that next slide. LCFA is a long-chain fatty acid, and primarily they are used as an antiviral agent, enveloped in antiviral agent. They are also used against as a microbicidal product, that is feed sanitizer as a feed acidifier. But certain products are also available in the market that acts primarily on the envelope viruses, because LCFA are lipophilic in nature. And since it has a high pK value, even it can act deep down the chicken gut. Because I mentioned that pK value is the pH at which 50% of the organic acids are dissociated. So as the pH of the environment increases, the organic acid will start getting dissociated. Once it is dissociated, the H+ hydrogen ion will call acidification. So more the pK value of the organic acid deep down in the chicken gut, like mid gut and up to before reaching the hindgut, it can act. Although all these organic acid will get finished before it enters even in the midgut, or before reaching the hindgut. So the variants like DSSFA, that is derivatives of saturated straight chain fatty acids, are also used in the drinking water sanitization because of its efficacy against both gram-positive, gram-negative bacteria. There's fumaric acid, lactic acid, and sorbic acid. Here I'm explaining it in more detail, how the organic acids, they mediate, antimicrobial activity. So first of all, this is the undissociated form. I was talking about the pK value where 50%, the pH at which 50% of organic acids are dissociated. So more the pH of the environment, higher the dissociation of organic acid will happen. So the undissociated form means the structure is intact, RCOOH. As the pK value, the pH of the organic acid, of the environment increases, the dissociation will also increase. So at pH, for example, if you see here, the formic acid, it has a pK value of 3.75, or say acetic acid, a pK value of 4.76. So when this acetic acid is at pH 7, its pK value is 4.76. So when it is in pH 7, you can consider, just a second. When it is at pH 7, you can consider 100% of the organic of the acetic acid is in dissociated form. There is no undissociated form. The whole of the acetic acid is dissociated. So it exerts a bacteriostatic effect in dissociated form, because in dissociated form, it liberates hydrogen ion. Hydrogen ion will reduce the pH, while the bactericidal effect is imparted through undissociated form. And this is not happening for all the short chain fatty acids, but for selective short chain fatty acids. But for long chain fatty acids like lauric acid and all, they are very potent in exerting bactericidal activity, because they are more lipophilic also. And also the pK value of lauric acid, or because of having long chain also, the pK value is on the higher side, and that's why they remain in undissociated form better than the short chain fatty acid. So in a nutshell, in undissociated form, it will enter into the bacterial cell because it's lipophilic in nature, while in dissociated form, it cannot enter into the bacterial cell. It primarily will reduce the pH of the environment, and with that, it will have a static action because the pH sensitive bacteria won't be able to grow. So undissociated form, it enters the bacterial cell. In the bacterial cell, in the cell cytoplasm, the pH within the cell cytoplasm of bacteria is normally on the alkaline side, and that would cause dissociation of the organic acid, which was undissociated form outside the cell. One side inside the cell, it is dissociated, it will start producing hydrogen ion and would lower the pH of the bacteria in bacterial cytoplasm. And this in turn, the bacteria will try to, pump out the hydrogen ion from inside the cell so as to restore the original pH of the cytoplasm. And this would turn, cause exhaustion of, they will deploy a lot of ATPase pump, sodium, potassium ATPase pump, to flush out the hydrogen ion outside the cell. And doing that, they would suffer a lot of energy depletion and eventually dies. So that is how it is producing the bactericidal effect. So primarily, all the organic acids, most of the SCFAs, and you have seen exhaustive list of SCFAs. Most SCF, in the bulk of organic acids are made out of SCFAs in poultry feed or drinking water, and they are primarily bacteriostatic in action. And here one more point is that the SCFA and MCFA, they work already I mentioned by lowering pH, so they are bacteriostatic, but they have very strong impact on gram-negative bacteria. And it has been shown that acetic acid and butyric acid, formic acid can enter the gram-negative bacterial cell like Escherichia coli and can render bactericidal effect, render them inactive. And this is not possible with the LCFA because they are more lipophilic in gram-positive bacteria, but the lipopolysaccharide in the gram-negative bacteria, that is in E. coli, doesn't allow the entry of LCFA, although it is lipophilic from gram-positive bacteria. And also it is more in undissociated form at high pH. So you need to use a blend of its SCFA, MCFA, and LCFA for a comprehensive action against all types of bacteria at different pH level. This is for water or acidification I was talking. What about when we apply in the water or in the feed? What about its interaction with probiotics? With essential oils, there are potential risk of using probiotics like lactobacilli. It could have a detrimental effect on the probiotic species. And the spore formers like Bacillus subtilis or Bacillus siamensis, they are relatively more resistant than the vegetative organisms like lactobacillus. But what about organic acids with these probiotics? Similar trend exists where lab bacteria has been shown specifically sensitive to SCFAs, which acts by lowering pH. And if the pH is reducing even lower than 4, these lactobacillus species count decreases. And many research publications are available showing this point that acetic acid or formic acid does not favor lactic acid bacteria, specifically when you are aggressively lowering the pH. And it has been shown that the application of spore forming probiotics like Bacillus species like Bacillus siamensis, we have tested Bacillus subtilis, they are more practical and relevant because they are relatively more resistant to these organic acids. In fact, organic acid application between 5 to 6 favors the growth of Bacillus subtilis, which in turn will favor the growth of Lactobacillus acidophilus or other lactobacilli species. What will happen that if we try to acidify the feed? Till now, we are talking about acidification of water, the potential advantage of having blends of different SCFAs, MCFAs, and LCFAs, and how these organic acids are restricted to the upper gastrointestinal tract of the chicken, because in lower gastrointestinal tract, they are almost exhausted by getting dissociated. If you want to get an action in the hindgut, we need to think about targeted delivery. That's what we use for butyric acid, because butyric acid also having pK value less than 5. In feed, what happens? Feed, we have another additional challenge. See, these organic acids act by reducing pH. That is by liberating hydrogen ion. In poultry feed, there are certain components like proteins and minerals which have their intrinsic buffering capacity or acid binding capacity. It doesn't allow change of pH. This is called B value of the feed, which means you need to add more concentration of organic acid that would actually require to inhibit the growth of mold or bacteria. And for this, the efficacy of organic acid, cost of the product, cost of inclusion also increases. So the latest solution that is being suggested is use of components like surfactants, which increases the efficacy of organic acids, and formaldehyde, which is safe, although people have this misconception that it is affecting the chicken gut, specifically commercial layers and breeders. No, this formaldehyde that is used is not in very high concentration. Its action is limited to the feed sanitation effect only. I personally have used this kind of product. And use of surfactants, which convert the free water to bound water in the raw material, and also enhances the entry of these organic acids in the cereal ingredients, helps solve the situation. So this is a constant. Please remember, you need to use a combination of surfactants or formaldehyde, a product containing this kind of composition, to mitigate the challenges of buffering capacity of the feed. So with that, I have left with 2 slides. I think we'll be able to complete by time. We'll talk just briefly about optimizing application of probiotics. Now, just to give you this perspective that people think that probiotic, once given, it grows and replicates inside the gut. So a period of say 7 days of application would ensure me 30 days of integrity, gut integrity. This is not going to be the case, because once you give a probiotic, it will, if it is a spore former, it will germinate, it will colonize, and it will slough off with the sloughing of intestinal epithelial cells. So a study done by Cutman et al. In 2008 was an eye opener. These people, I mean, these researchers, they fed 1 billion spores of a probiotic one time and studied the chicken gut tissue at different time intervals till 7th day. So this is log number of spores you can see on the y-axis. So 1 billion means 10 to the power 9 spores. And they studied the number of spores after 6 hours, 12 hours, 20 hours at different section of chicken gut. They preferably used the hind gut for the study. So this is somewhere in the jejunum and ileum. This is in the ceca, this is in the colon. And after every 6 hours, 6, then 8 hours, then next 48 hours, they have seen a drastic reduction of the count of the spores in the chicken gut. So by the time it has reached 168 hours, that is 7th day, the count has reduced from 1 billion to 1,000, that is 10 to the power 3. So it was told that probiotics are transient passenger of the chicken gut. These workers, they have claimed that they are not going to be permanent resident inside the gut. Constant loss happens, and state of equilibrium will be achieved if we keep on supplementing the loss. It should be applied as early as possible in the hatchery, because once the flora has got matured, you can't influence them by its application. And right concentration of application is very, very important from the beginning. So you can see on the right hand side, a calculation has been given, and various publications, research publication has shown that 0.1 billion, these workers have used minimum 0.1 billion of probiotic exposure. So maximum 1 billion exposure per bird per day, or 0.1 billion is the minimum. 0.1 billion exposure of probiotic per bird per day is required. This is to fight off infection, enteric infection or enteric challenge in absence of any antibiotic. So to achieve this number, if you see in the perspective of the feed intake and the concentration of the probiotic spore available in the product, for example, say product containing 2 billion CFU per gram and the inclusion level of 500 gram per ton, and the broiler feed they're consuming about 30 gram per day during first 10 days, would end up having 0.03 billion spores only exposure. That is almost 30% of the minimum requirement. 0.03 billion versus 0.1 billion. This is the minimum, not less than. After 20 days only, when the feed has reached above 100 gram intake per bird per day, it has crossed the minimum inclusion exposure level, that is 0.1 billion per bird. In case of commercial layers, the average intake is around 10 gram per bird day during first 7 days and 13 to 14 gram per day during first 7 to and the next 7 to 14 days. In such case, the condition is much worse than the broilers even, and it is almost 10 times lesser than what the minimum level. So with such situation, it cannot be expected that you are going to get the coverage or protection from probiotic. Of course, you need to have that strain characterized, all of the data that I have shared previously. Right quality strain with this level of exposure, you cannot get the coverage. So for that, you need to ensure early application of water-soluble probiotic because of the lower feed intake of the bird, and that too the right quality strain. Then only you can ensure that you can have consistent result. You can replace the AGP or antibiotics with probiotics. So here is the executive summary and conclusion. To achieve the consistent probiotic effects, characterization and evaluation of probiotic strain is critical before it goes in the commercial product. And without that, you are not sure what you are using, whether it is safe or not, whether there are toxic, toxicity of the strain, whether it is at all stable in the chicken gut. So strain level calculation is extremely important. Already it is mandatory for human probiotics. And also to have a certification of GRAS that we call as generally recognized as safe, we need to do this characterization of strain. Early application of probiotic at recommended concentration per bird can make significant difference. And holistic approach, that is combination of prebiotic, probiotic, and organic acid, and essential oil. That too, we need to ensure that there should not be any antagonism, like I told about essential oil and certain organic acid with lab bacteria, lactic acid bacteria. We need to understand that interaction to ensure total gut integrity in poultry in absence of antibiotics and MFA. Thank you very much, and I am open to the question and answer session.
Thank you very much, Dr. Susim, for your wonderful talk. It's always a pleasure to hear you speak on different topics of poultry. I'm sure the participants must have developed a greater insight to the use of prebiotics, probiotics, essential oils, and acidifiers in poultry feed. Some must be having questions hovering around their mind. Please feel free to drop your questions in chat box, or you may simply unmute your microphone and put your questions. Please. So I can see there are a couple of questions. Can you please look into the chat box, Dr. Susim?
Yeah. So I can see your views on some anonymous post.
Simultaneous.
Yeah, your views. No, some anonymous post. I don't know who have asked this. Your views on simultaneous use of sanitizers
that was my question actually.
Okay, didecyl and dimethyl ammonium chloride and probiotic. Oh my God. So you can't use them both. See, didecyl dimethyl ammonium chloride, Socrena, Quaternera 4, although it's recommended as a water sanitizer, because didecyl, any quaternary ammonium compound, although in the lowest possible concentration, it could be safe for the shorter life cycle birds like broiler chickens. They are there for 35 to 42 days. But what about for commercial layers and breeders? Quaternary ammonium compound is toxic. If you give in the lowest amount, although they are marketed as a water sanitizer, by the way, but for broilers, probably it's okay. Scientifically, if you use a quaternary ammonium compound, if you use in low dose, it will take a long time to produce a chronic effect. I mean, it's a chronic effect, it's detrimental effect, but it is toxic. Only WHO recommended or OI recommended water sanitizer is chlorine compounds. And that too, hydrogen peroxide in absence of birds, that is also causing peroxidation or oxidation of the chicken gut. But if you're using in combination with probiotic, it is not going to work. Never going to work. The best possible way to use probiotic in the first 7 to 10 days of chick's life, that feed calculation, because the optimum level of probiotic exposure is required. To achieve that, you need to use organic acids. And need to avoid certain probiotic also that is susceptible to organic acid. For example, lactic acid bacteria, they are not resistant to short chain fatty acids like acetic acid and formic acid. And even one interesting point is that certain short chain fatty acids like acetic acids, they favor the growth of pathogens sometimes, because E. coli can use a short chain fatty acid like acetic acid as a source of nutrient. The carbon backbone is used as a source of nutrient for fermentation. Not all the times this is there. So you can't use straight away. Better to use organic acid. What about simultaneous use of acidifier plus probiotic or sanitizer plus acidifier? See, acidifier per probiotic can be used, but lab bacteria, you need to ensure whether they are sensitive or not. In my opinion, avoid using these bacteria which are non-spore former. Lactic acid bacteria, they cannot form spores. Non-spore forming bacteria reduces the chances that they can survive in any of the harsh environment. So acidification is a harsh environment for them. And if I'm talking about sanitization, or sanitizer plus acidifier, where formaldehyde is present, absolutely you can't use a vegetative bacteria like lactic acid bacteria. In practical use, can grade of farmers A, B, C affect the efficacy of probiotic? Efficacy of prebiotic and probiotic. Grade means quality of poultry farm management practice. Equipment. Okay. Affect, I'm not able to understand the question, whether what he's asking, that whether how to measure the efficacy of probiotic in existing farming practices.
Okay, Omkar Singh, sir, you can just unmute your microphone and make the question clear. Singh, sir.
Hello. Yeah. Hi, Mukul.
Hi.
This is
Hello.
Omkar
Hi.
Singh.
Yeah, please.
How are you?
I'm fine. Pleasure.
Okay. Actually, I was wondering whether, in poultry, whatever I'm talking in a very practical sense, having effect of all probiotic, prebiotic at the farm level. So whether the for example, if we have a grading system of all the farms, it is always that A category farmers performs far better than C category farmers. I mean, the difference in FCRs are sometimes 10 points for A, B, and C. Like if at all A grade farmers are achieving say around 1.5 C FCR, B will achieve 1.6 FCR, and C will achieve 1.7 FCR. So and this is only because of their management practices on the farm itself, their attention to the farm itself, their handling of crisis or handling of daily activities, maybe water management and feed management on a daily basis. That is how they differ. That is how the difference comes in ultimately FCRs. That is what I wanted to say. If at all you give probiotic to A, B, and C, their effect will be better at A, their effect will be same at C.
So it could have I understand where you are coming from. It will have a modest effect on C. The farm having the excellent management. See, managemental intervention does not undermine, to answer your question in one line. In India, this is very true. In integration, it is extremely important to find a good farmer first. Yes. Where you are handing over your chicks, your meticulously formulated feed to get the better result. You are just resting your fate in the hands of the other. But just to give you one sort of answer, you have large experience handling farmers, but we have done a lot of experiment here also in the field since my days in integration. Changing in the management will not undermine the fullest potential of probiotic. What I meant to say is that if you make a very good formulation, highly digestible nutrient, the difference of probiotic with the control will be reduced. The gap will be reduced. I'm again repeating, if you are making a very digestible, highly nutrient dense diet and you are giving a probiotic and you are having a control, the difference won't be much. But if the management is poor in one of the farm and better in another of the farm, it doesn't have that narrowing effect on the performance of the probiotic. In the farm C, because that difference will be created by the richness of the formulation. Where giving probiotic, you won't find a much better result than not giving any probiotic when your formulation itself is very good. But one point that might help in performance of probiotic better in C is because the C farmer has a poor management. Poor management means I'm assuming there will be poor water quality, poor litter quality. All this stress factor would have a negative effect and in presence and on the gut health. And the negative factor on the gut health helps the probiotic shine. I told that if you do not have a challenge in the gut, the fullest potential of the probiotic is not exhibited. Some sort of challenge should be there. Then you can see that negative, the the difference between the control and the treatment. So probably in the farm C, you will see a better effect of the probiotic than the farm A.
Exactly.
But don't make
that is what I was keen on. Like for example, there are three children. Children. One is performing 90% in their exam. Other is performing 70% in exam, and the third is performing say 40% in exam. And if you provide them a very good tutor,
very easy question paper. Very easy question paper for all three of them, then the marks difference won't be great.
No.
Almost same
I mean
across
to
students.
say, if you provide a very good tutor, the 90% student may get 92%.
Right.
But the B student who gets 75%, he may reach 80%. But if you see the C level, if he gets a very good tutor, he may get maybe 65%. So the rate of improvement is far better in C than A. The same thing will apply. I will try to compare this probiotic and prebiotic to that good tutor. So that means it will perform better in a C student than in a A student. Is it right?
Right.
Because our balance sheet goes down because of B and C and not because of A.
Yes. You have to take care of those B's and C's to pull up your average performance.
These are the trouble creator. These are the loss creator farmers in our like in our balance sheet. So this will act far better way than the A grade farmer.
Right.
That's
and
what
also
I want
if the question paper is very easy for all these guys, A, B, and C student, then also the marks difference across A, B, and C would be narrow. This means I'm comparing this with the feed formulation. If the nutrition is great, then the difference between A and B might be narrow. But for C, because of the poor management, the gut health is impacted. The difference will be wider.
Yes. That is what I was keen on getting that answer. Whether it will impact. I'm more keen on whether it impacts far better to the C than the A.
Yeah.
Because A is anyway perform.
Yes. And strain characterization is important. You need to have right strain in the probiotic to see all these effects coming in. Otherwise, it's more simple. Thank you
very much. Thank you very much.
Thank you. Yeah, the next question is, can we use garlic, onion, and such traditional used herbs along with probiotics? Yes, there are also essential oils. But the concentration of these essential oils are very important. What we use in the feed, you see, it's the graph that I've shown. It contains it showed that the thermol and carbachol have MIC around 150 to 350 ppm. ppm means milligram per kg diet, a gram per ton. Do you think that you are using the essential oils in the feed at that concentration? Then only it will have a detrimental effect on the gram pathogens as well as the probiotics. So, this is important that you need to check what concentration of essential oil you are using. Essential oils are yet to be explored in a proper way in the feed. In my belief, they are more thoroughly studied to treat respiratory ailments. They are available in the feed as a feed additive, but due to higher inclusion cost and also due to the dilemma of or a contraindication with certain other product like component like probiotics, their use are not very regular. But of course, you can use. They have an antiviral, antibacterial effect, right? Can you use yogurt as well along with probiotics? In chicken, I would always prefer to use a characterized strain in my probiotic diet because I need to ensure that because the margin of error is less with these high performing classes of birds and breeds. So we need to be sure about that the strain of probiotic that I'm using should be absolutely effective against the relevant pathogen for my birds, like gram-negative, gram-positive bacteria, and they are having good performance boosting effect. So in yogurt and other probiotics, definitely it will improve, but we don't have the complete knowledge of the strains that are present. How much more effective is spraying the chickens with essential oil solution than giving them to the feed or drinking water to relieve respiratory problems, or is spraying recommended at all? Spraying would have a direct impact. They are more as a symptomatic relief. You won't expect a very strong antiviral effect or antibacterial effect by spraying, because it largely also depends on the concentration of the essential oils the company is providing you in the product. So, but at low concentration, it won't have an antimicrobial effect, but it will definitely have those symptom, symptom relieving effects, alleviating effects like bronchodilation, like antihistaminic action or anti-allergic action, where it reduces the respiratory rails, the respiratory secretion, freeing up the respiratory airways, bronchodilation, higher, diameter of the airways, so that they have ease in breathing. So, and when you are spraying it, you have to make the house close and expose the bird for at least 20-30 minutes, just like this. Before we use this, it gives a symptomatic relief from nasal congestion, and we can take air in freely. This is how we have to simulate. For that product, if you're using in drinking water, you have to check with the company's composition, what concentration you are giving. Just remember the ppm level, 150 to 300 ppm is required to exert antimicrobial effect in the chicken gut or the bacteria that those are relevant for poultry. If you have that concentration of essential oil, you can go ahead with in the drinking water. Yes, I think I finished all the questions that have been posted.
Okay, thank you very much. Am I audible?
Yeah, sure, you are audible.
Yeah, because unfortunately power cut off happened here, and I am in through my mobile data. Thank you very much, Dr. Susim, for your generosity and valuable time. Thank you very much, especially for being ready to help us on such a short notice. Thank you for your insightful talk and for all the satisfying answer to the questions raised by our enthusiastic participants. We look forward to cooperating with you in future as well to disseminate the knowledge, information, whatever experience and expertise you have for the benefit of global livestock, poultry, and feed industry. Thank you very much.
Thank you. Bye-bye.